Hello guys, I am Renalty Saladaga, and today I will show you an Excel program for design of reinforced concrete rectangular beam using WSD method and USD method. Now, before we input some values here in WSD method, make sure that the add-in is in the Excel, or the solver add-in is in your Excel. And so for us to know if this program will work, let's have an example. So let's say we have a live load of 50, dead load of 30, length of 3 meters, 16 millimeter diameter, steel strength of 276, 227.6 compression strength, and a modular ratio of 8. By the way, we must assume that our B, or the width of our beam, will be equal to the effective depth over 2, which is in the ACI specification. So in the computed values, we will get the total loadings of 80 kilonewton per meter, and we will get a moment of 90 kilonewton meter. Then we will get also our K constant and J constant, which are 0.264 and 0.911 respectively. So here in the dimension values, we must set a value of our depth first. Let's say, for example, we have a effective depth of 1, and so that's not the correct value, right? So for us to get the right value of our effective depth, just click the data here and click the solver, and make sure that click this value off and change this to 1, and then click solve, click OK, and so we'll get the effective depth, which is 493.38376. So for safety design, we must assume a higher value of this. So let's say 496, and so we will get the width of 248 mm. We will get the area of steel of 732.62 square millimeter, and number of bars are 3.646. Let's say 4 number of bars, and so we will get the section of our beam, which has a 496 effective depth, 248 width, and a 416 millimeter diameter steel bar. So I guess that's it for the WSD method. Now let's go for the USD method. So here in USD method, we are using the 2010 or 2015 specification. So basically, if you have a problem of 2001 specification, you can't use this Excel program. By the way, this Excel program only supports simply supported beam. So again, for us to check if this program works, let us have an example. Let's say we have a uniform live load of 24, uniform dead load of 12, the length of the beam is, let's say, 6, point live load of 36 at the mid span here, and dead load of 618 at mid span again. Also, we have 415 MPa steel strength and 28 megapascal of compressive strength. And so here in the computed values, we will get the ultimate point load of 79.2 kilonewton, ultimate uniform load of 52.8 kilonewton meter. So we will get the reactions in the simply supported beams of 198 kilonewton. Moment at support is 217.8. The moment at midspan is 136 138.6. So we will get our fee balance, which is 0.288, our fee max 0.0216, and our fee min, which is 0.003. And since we have a compressive strength of 28 here, we will get the value of our beta, which is 0.85. If we go higher than 28, let's say 29, and so it will change directly into 0.68, 65 rather. And so we will get our M constant of 17.436, control deviation of for phi of 0.0121. We will get the RU of 4.506. This will become our initial RU, MPa. And so we can't get the values of preceding value because we don't have value of our width and height. So let's assume a value of our width, which is, let's say, 300. And so we will get our H initial, which is 485.59 millimeter. Now, in order to be safe, we must set it higher. So let's say, for example, 500 millimeter of height of your beam. And so we will get our RU for support, which is 4.21, RU for midspan 2.68, our phi for the support is 0.0112, and phi for midspan is 0.006 or 7. Also, we have phi index of 0.9 for safer design for tension control. So we will set the value of our diameter of the bar, let's say 25 millimeter, and for the midspan also 25 millimeter. And so we will get the number of bars. So in order to be safe, let's set that to 4, and here let's set this to 2. And so we will check if our cross section is okay or not. So here at the support section is not okay, and the midspan is okay. So this only indicates that we must add another layer for our bars. So let's say we have 2 layers of bars, and then we have 2 bars per layer, and so it says okay here. So I guess that's so we can see here at the cross section of our beam at the support and midspan section, we have total of 500 height, 437.5 of effective depth, and 300 width. So at the support section, we have 2 25 millimeter diameter and 2 25 millimeter diameter at the top. But remember, we set this to 2 layer, so you must add here a 2 and 25 here at the left, but let us not put it there. Just you can see that you must use these 225. So after that, at the midspan, you have 2 25 millimeter diameter at the top and 2 25 millimeter at the bottom also. So that's it. Thank you.